Okay, so this is the explanation video for problem number 4 of Exam2. Well, the problem we had was that even though the initial code was able to calculate the constant pi, the program did not work perfectly because the amount of intervals for the parallel computation was not exactly divisible by the amount of core. So the problem was something like this, where imagine this is a pie chart, the graph for the calculation of pi, and the first chunk of the graph was assigned to thread number 0, the second part to thread number 1, then thread number 2 and thread number 3, supposing that we had 4 cores in, well, for the calculation, right? So the solution we applied for the code, well, first of all, I have to mention that we had some trouble with the long variable, as it had some overflow, and well, we managed to fix that problem, adding another long to this variable, the amount of intervals, cantidad de intervalos. And well, in this part we return the number of cores that we suppose the system had. We did it manually, and well, here we have the thread routine where we implemented the solution. The first thing we changed was the initial legs, as before we had that to the thread was sent the initial value for each chunk and the dimension that it had to reach for each thread. So well, the solution was that we changed the x initial and we assigned for the initial x the value of my number of thread multiplied by the base interval, and also the condition was changed to x less than 1, and the final number, well, the final number should be less than 1, as we saw that in the graph the final value of the interval was 1. We integrated from 0 to 1, and well, then we increase the step, the amount of the base interval multiplied by the number of threads. And well, the example we gave was that when having 4 cores, the first thread, this is thread number 0, will start in 0, then the interval number 4, then the interval number 8, and well, the thread number 1 will have the interval number 1, interval number 5, 9, etc. Thread number 2 will have 2, 6, 10, and so on. Well, and here's some kind of explanation, the difference between the both solutions. In this case, the chunks were too big, so maybe you will take more or less information that you should. And in our solution, well, as you take very little intervals, then you have less error for each case. For example, here we suppose that well, in the last value, as here we have x less than 1, well, the thread number 3 will be used in the last case because, well, x we have reached the final value. So this is a more exact computation, as you take interval by interval and assign it to each thread. Well, that was our solution. Yeah, maybe we can make some trials. Let's run. And there's the computation. Well, it was pretty fast. Last time was a little bit slower, but well, we have a very good approximation, and that's it.